First, I want to thank the staff for the boot camp. It was absolutely an incredible experience. I learned so much. And the objective of this was to take some of the things I learned and to bring them into my day job. So you'll kind of get that theme as we go through this, and hopefully it will be of interest to you. So what I ended up building was a chatbot. It's no agents. Maybe if I take the boot camp again, it will definitely be agentic, but I focused on the chatbot experience and I focused on the exchange between the provider, which you can see here, a healthcare provider, and a health plan like Medi-Cal. So I picked Medi-Cal because it's a large health plan. There's a large corpus of docs. And on another application I worked on in my past, it's actually surprising how many providers, right, like doctors' offices call into the health plan to get information about eligibility requirements. Because of course, if you go to your doctor, they have to support hundreds, if not thousands of health plans, right? So that's why I focused on this. A couple of things that I tried to focus on and I talk about a little bit later, accuracy and latency. Um, so if I don't show some of that in the demo, I talk about in the roadmap some things that we can do to improve that. So let me just get into some more of the details. So these things are actually surprisingly hard to build, right? So if you take a look at this as a class of applications, which are just RAG apps in general, and you've heard a lot of that, I think pretty much every application we've seen tonight has that component because it's really what enterprises want, right? And I think that everybody knows that. This app is really no different. It's tackling RAG. What I'm trying to do is to show some techniques to make it simpler. I'll show you architectural decisions that were made to simplify some of the construction because as I learned in the class, and I kind of knew some of this a little bit beforehand, there's just an overwhelming amount of choices that you can make, right? It's really incredible. That makes it super exciting for people that are in boot camps like this, right? To learn all these really cool things. You really are at the cutting edge of a whole new way to develop applications. Super intensive, lots and lots of effort to go from like 80% accuracy to 90% accuracy on your answers. The evaluations can also be super complex. LLMs evaluating the answers. Do I need a human? If I need a human, it gets really, really complicated because there could be thousands of variations on the question. So there's just a lot of things to figure out. Why did I use Medi-Cal? There's a large number of documents. I thought it was fairly realistic. So there's 196 documents that are part of the Medi-Cal provider set, right? So this is the provider manual set, not the health plan, the provider set. So these are the documents that a provider would look at to make a determination about whether you, a member, can get coverage. So for example, if you take a look at chiropractic services on the right-hand side, program coverage, services are limited to a maximum of 2 services per calendar month. It's important information, right? If you come in for 3, you as the member are going to get billed for 1, right? So super important information. The member will expect the provider to know this and tell them, hey, you're going to get billed for this if you want to do a 3rd. I personally have had this happen to me, so it's something I'm sensitive to. What am I trying to simplify? We used the diagram on the left, which I'm sure you're all familiar with, as a cornerstone for the course. I thought it was super interesting. I'd never seen it before I took the boot camp. I'm really focused on the stuff that's in the red box. There's other areas that we can simplify using different techniques like the advanced prompt engineering stuff that we talked about, evaluations, but I really focused on the embedding model vector database. How could we make this simpler? And I also evaluated and tried different options, which I'll talk about at the end. You can see on the right-hand side, which I'll show you when I get to my demo, the tool that I used, right? The service that I used in the Google Cloud platform to simplify this, which is something called, and you can see this down here, Vertex AI Agent Builder Data Store. This isn't an advertisement for Google Cloud. I'm sure AWS and Azure have equally fine services, but my intent was to use services from my employer to see if I could simplify and integrate that with the things that I learned during class. Here's the architecture, right? So I use a service called Cloud Run, which is basically Knative, right? For those of you that are familiar with that, it runs on Kubernetes. It's containerized. LangChain, which I really hadn't used before I took the boot camp. I love LangChain. I think it's incredible. Great orchestrator. I use Gemini, of course, and Gemini Flash for latency reasons. Vertex AI, the data store, which I showed you on the previous slide. And then the documents come in via cloud storage, and then they're ingested into the Vertex AI data store, which goes through and parses them and chunks them and creates the embeddings. So that's the architecture, right? And then what we can do is use the LangChain community libraries to go through and build an expression language chain, an LCL, and then that will pull information out of the data store as a retriever and then give it to Gemini. So architecture summary, LangChain is the orchestrator, Flash for latency reasons as opposed to Pro, right? So we have two sort of main versions of the closed source model. Chainlit, which is super easy to get up and running. I didn't do a lot of customization on the Chainlit UI, but it certainly worked well. I did implement conversation memory, which was a really interesting exercise. My vector DB is the agent builder data store. I did Ragas for evaluation. I did run into some issues here with the size of the corpus. I was constantly hitting rate limits. So I did a synthetic data set for a single document on a previous corpus I was looking at, but when I tried to do it with this one, I kept hitting rate limits. So that's something I would like to revisit at some point because I would like to get the Ragas evaluations to run across the various techniques that I used. And for observability, I use Langsmith, which is again absolutely an amazing product. And to me, then I'll show you some of that when I get to the demo. Okay. So let's talk about the roadmap before I move to the demo. What are some things that would be needed to industrialize this, right? To make it really enterprise ready. One is prove the accuracy of the responses, right? It's a regulated industry. You heard earlier about the financial services business, I think, from Vinod. Same thing with healthcare. Super important. One of the ways that that's mitigated that I've seen in practice is even though you have a chatbot, there's a person in the middle which interprets the answers, right? So you have a human in the loop. So the provider is actually calling in. That person you call into is using the chatbot to assist them in their work, right? There's obvious disadvantages associated with that. One is, you still have to have the person there. A lot of organizations to deploy these technologies would like the direct interaction between the member and the chatbot, but they need to make sure that the answers are almost perfect. And as you guys on this call know, that requires a ton of work. So use a human-generated golden data set in addition to synthetic, right? That's one way to improve accuracy. Develop and implement a way to quickly and cheaply evaluate your application. This is one of the things that I think if we think about this as for those of you that are app developers, like what we did with CI/CD and various levels of testing, including integration testing, having the pipeline when we change the prompt or change the model, do similar types of evaluations would be super, super helpful. Adding citations. This is something I wish I had done. Didn't have time yet. I saw that in the previous example, which was terrific. Citations are obviously important. You want to be able to click through and see the provider manual. Personalization using member details. So when we look at a healthcare situation, even if it's a provider situation, although less important for the provider, because I think that you're looking for kind of the general guidance. But if you look at building one of these from the member, you have to look at, the person's gender, their specific policy, their age, et cetera. One of the ways to extract that information is via something like a Redis cache based on the member ID that gets passed into the query and then it gets injected into the prompt, right? So I've seen applications where that's worked in the past. So it's a pretty effective technique, but it takes a lot of data or a lot of work to get the member details in a tight format, especially in an enterprise system where you might have 50 or 60 different systems. Okay, so the other on the response drift and latency. So I'm gonna go ahead and hold off on those. Let me go ahead and show you the demo, take you through this real quick. So here's the data store. You can see all the different manuals. Down here, there's a whole bunch of different ones. These are the PDFs. There's one Excel file that sits in there. This is the actual Cloud Run service, okay, which is right here. This is the Chainlit app for the Cloud Run service. Let's bring over some questions like, what are the diabetes implementation requirements? You can see it comes back pretty quickly. And then we can take a look at Langsmith, which gives us some really cool data. So for example, if I open up the chat Google Gemini AI. I can see the prompt that's being used. And I can also see the conversation history that's injected down here at the bottom. So this is really, really helpful stuff. So, okay. I think you covered everything that I wanted to cover. So thank you for your time, and I hope you found this interesting.